Lift it up less.
End it here? No.
Yeah. So we grab.
Please.
No.
If you think about it, though,
Okay,
doesn't that?
just a few more, because this is like just explanation, so we really just have to get through these three problems.
we doing arc length then?
We're doing arc length, but it doesn't take long. Okay, bear with me. Okay, so we've got this function. Let's see if I factor it, just to see what it looks like.
Take out an x squared.
Yeah, I did grouping. So then we know it's x plus 1, x minus 1, x minus 3, right? Okay, so on our graph, it intersects at -1, 1, and 3. And it's a cubic, so cubics start down here, and it'll go through all 3. Okay. Everybody good?
Oh, this is like algebra.
Yeah, algebra 2, right?
Yay.
All right, we want to know the area from -1 all the way up to 2. So if it's asking for area, we're not gonna like add this and take that away. We want both of them added together. So there's 2 ways you can approach this problem because you want to make both the areas positive. The 2 ways is to integrate from -1 to 1 and go top curve, which is,
X squared minus 1.
yeah, I'm not going to even, I'm going to rename this, instead of y, I'm going to rename it f of x. Okay. Because if I rename it f of x, then I don't have to do, like, write it all out. So -1 to 1 of f of x. Really it's -0, but you don't have to do it. The minus the 0 part. And then add the integral from 1 to 2 of 0, top is 0, minus f of x. And then that will get you the area. But there's multiple ways you could do it. You could do it that way. You could switch the bounds to make it positive. You could do absolute value. Whatever way you want to do it. Okay, let me show you how, because for a lot of these you'll be able to use your calculator. Is there a glare?
Yep.
Does that help?
Nope.
Does anybody have an old calculator? Like one that's not like
The
on
I-84.
screen? And I can borrow, we'll switch. Thanks. That's okay. Thank you. Okay. So if you go to y equals and you plug this function in, x to the third minus 3x squared minus x plus 3. Then when we go to our home screen and we integrate -1 to 1, and then we get y1. You can do -0 if you want. And then plus math 9, 1 to 2, y1, no, 0 minus y1 dx. Or maybe you should get your area. 5.75. Okay.
So we'd be allowed to use a calculator?
Yeah. For these ones up here, you don't need it. But like, once it gets a little harder, you'll be able to use your calculator. Okay, all good?
So to do it by hand, do you just have to just do regular? Like,
Yeah, you'd have to solve these like integrate it, solve it out, and then simplify.
How do you put
But-
y1 again? What do you do?
Alpha F4, like alpha trace.
Okay.
And then the first one is y1. You can choose whichever one you want.
Got it.
Okay. The next one is find the area of the region bounded by x equals 3y minus y squared and y equals x minus 1. So,
Miss Moy,
yes.
going back to example number 4, so I did not factor out anything, and I didn't really draw it out. I just did from the bounds, and I got 5.75.
So, what do you mean?
Like I did the interval by hand from -1 to 2.
You would get 2.25. Did you do the top in minus the bottom in?
I think I might have, maybe I switched the bounds.
Or maybe you, like, when you, yeah.
Okay.
Maybe that was it.
In this case,
Or something happened probably with your minus.
Oh, shit.
But it ended up being right, so.
yeah.
Do you. Okay. This one is x equals 3 minus y squared. That is a parabola opening to the left, shifted 3. And then this is y equals x minus 1. So y-intercept of -1. And then it goes like that. Okay. All right. So if I were to type this in the calculator and get y equals, the only way that I could do it, I could do the x minus 1, 1, right? But the only way to do this parabola right here is to do a positive root 3 minus x and a negative root 3 minus x. So then it would look, then we would have the 3 parts. So that it would graph that, right? Because otherwise there's no way to write it as a function without having the top half and the bottom half. And then this is x minus 1, right? So if you are finding the area between the two curves of this one, the problem is I have to calculate the area from here to here, because I'm going from the line to the bottom, root 3 at minus x, and then I have to calculate a different area from positive root 3 minus x to negative root 3 minus x for my second area, right? Yeah. Do you get it? Because I'm going for this one, I'm going from the line to the parabola. And then from this one, I'm going from parabola to parabola.
Yeah.
So I have to switch it, right? But nobody likes doing that. So the other way to do it, I'm not even going to bother writing it that way because it takes way too long. The other way to do it is if you have the parabola here, is to write your equation in x equals, so it's x equals 3 minus y squared and then this one is x equals y plus 1, like if I solved this equation for x, right? And instead of going from top to bottom, the nice thing is if I go from right to left, then I'm hitting this equation for the whole thing to the straight line every single time, so I don't have to do 2 sections. Do you see the difference between the two functions? Like this one is written all in 3 minus y squared. That's the whole equation, so I can just go from the right side to the left side the whole time and not have to switch and cut it into 2 parts. Okay, so that's what I would prefer to do, is to go with respect to y instead and go from right to left. Okay, so the only thing I need to do is find these 2 intersection points, and then I can integrate it. So to find those 2 intersection points, we'll set them equal to each other and solve for y. So 3 minus y squared equals y plus 1. Okay, so I got 2 intersections, one at 2 and one at -1. No, one at -2, sorry, and one at +1. Okay. All right, so for my integral, we would want to do integral instead of top minus bottom, it's right. It's always going to be right minus left. And if you do right minus left, it's in terms of y instead, so dy. Okay, so we have c to d for this one. And these are y values. C and d are y values. So our integral will be from -2 to 1 y values, because it's from bottom to top. And then we're going right minus left. So the right curve is 3 minus y squared, and the left curve is y plus 1. And then it's dy. Okay. So 2 ways you can do it in the calculator. You can either do the integral and just replace all the y's with x's to find the integral. But some people don't feel comfortable like doing it that way, and they want it with the y's. So if you want it with the y's, you can still do your integral, but just use a y instead, which is alpha, and then number 1, there's a little y down there. So if you rather do that, then you can keep the y's there if you feel like. Doing it with the, oh no. Oh, I did? Uh-oh. 4.5, okay. Thanks. Okay, got it? All right, they're probably going to tell you which one you should probably do it in. Like, for example, they give you x equals y squared and x equals 3y plus 4. It's probably going to be a right minus left situation here. So let's do a little graph of y squared is a parabola that opens to the right this time. And 3y plus 4 it looks like this. But some people are like, how do you know that it's on the right hand side and not on the left hand side? Right? So there's 2 ways. You can either get this into y equals, and then you have slope intercept form, and then you can plot the slope and the y-intercept and graph it. Or you can choose like a value set them equal to each other first. So we have our, we're going from -1 to 4. So we have our two y values. So you choose a value in between -1 and 4, like 0. 0 is a good y value to choose. If I plug 0 into, for this y, what is x? 0. And if I plug 0 in for this y, what is x? 4. So which one is more right, the 0 or the 4? The x equals 4 is more to the right than the x equals 0. Right, so that's how you can choose which one is on the right-hand side, which one's on the left-hand side. You guys are looking at me weird. Do you kind of get it or no? Okay. No? No?
Wouldn't you just end up with a negative number if you just did it wrong?
No, like you're comparing. If I plug 0
No,
in for
I mean,
y.
like, if you flip them,
Yeah.
it would be a negative number. So just,
Then, yeah, you flip it back. Yeah.
So you plug 0 in for x.
So plug 0 in for x and you get 0, and then you plug 0 in for y and you get 4, right? And which one is more right, the 4 or the 0? The 4, so you know that this one is on the right
Okay, that makes
and this
sense.
one's on the left.
Just pretend like
Well, just 'cause like it says find the area, right?
That's
So
what I'm
even if you do it
So
wrong-
whatever it is, yeah, it's gotta be positive. It says find the area, it's all positive. Everything we do is positive. Okay, our integral will be from -1 to 4, because we're in y values. And then the right function, which is 3y plus 4, minus the left function, which is y squared dy. Okay? And then you can use your calculator to solve the rest. Do you like the y's or you like the x's?
The X's because they're easier.
Yeah.
Okay. The x's are easier. Because I keep writing x. 20.833. What's wrong?
Don't play.
Do you have a question?
I know you hit her up when you were
You good? Oh, because I was telling them if you don't know what to pick, like as like the right function and the left function, like if this graph wasn't here, like pick a number in between your intersections, and I chose 0 in between my intersections. So if I plug 0 in, I get an x value of 0 that's like here. And if I plug in 0 for y, I get an x value of 4. So then I know this line is more right than this parabola. That's how you know right. Yeah. Yeah, choose your y value in between your intersections. Okay, so for vertical, if you're doing vertical, it's top minus bottom with dx. For horizontal, it's right minus left. And then it's in terms of y. Any questions? All right, we're going to skip these two because we don't really need to do them. And we're going to go to arc length, which is a new
The other girls are like
Okay, so for these, it's actually really nice because you'll always get your calculator for these. You'll just need to know how to set up the integral for arc length. So let's say I want to find the whole length of like this whole curve, right?
Yeah.
Yeah. And so to find the actual length of that curve, what you do is you start by making little mini segments and calculating the length of each of these segments, and then adding them all together. It's not exact, right? So you want to calculate all the little lengths and then add them all together. And then if you increase the number of little lengths that you make, right, the more accurate your arc length. This is kind of just like Riemann sums, where
Oh yeah.
if we increase the number of rectangles, then we have more accurate area. This is the exact same thing, where if we increase the number of arc lengths, we get exact arc length, okay?
Yeah.
So we start with the length of one segment, and that's distance formula. Change in x plus change in y is your length of your curve, square rooted, right?
Yeah.
Yeah?
Sleepy owl.
Are you with me?
Yeah, I'm with you. I'm just, that's how I know this is Sleepy Owl.
Sleepy owl?
Yeah, you've never seen that one before?
No. Well, no, don't do it now. We'll do it later. Okay, so I changed this instead of changing x, changing y. I just chose delta x and delta y. Okay. Are you with me still?
Yep.
Yes.
All right. We want to find the length of each little segment, and then we want to add them all together. That's this. Yes? Are you with me?
Yeah.
So find all the little lengths and add them together, and you'll get arc length. Okay, and then this is where I start to get a little lost with this whole problem. So from here, everybody's okay up to adding all the little lengths together. Okay, everybody's okay with that, right? Okay, now we want to make the number of rectangles go to, number of little segments to go to infinity, right? Okay, and if I want the number of segments to go to infinity, then these little delta x's and delta y's need to turn into derivatives. So, instead of delta x, then I'm going to do a dx. Let's do dx in terms of x first. So dx squared plus dy dx, because they're little derivatives, squared. And I can't, this is not equivalent to this because I threw in a dx squared square rooted, right? Because I added that into my root. So I have to undo it by multiplying by dx on the outside.
Oh, and now you're saying
Okay, and then this is limit as n goes to infinity. And what happens, what's this whole thing? Like when I add up the sum of the number of things that go to infinity, that ends up being the integral, right? So your first formula is integral of dx simplifies to 1 plus dy dx squared dx. Okay, that's the one formula. It's on your paper. It says in terms of x right here. That's the one formula. Okay, we can do the same formula, but in terms of y. So this we'll divide by dy this time. So I can do the integral of square root dx dy squared plus 1 dy. That's your second arc length formula. That's on your paper. That's the one in terms of y. There's a third one that we're going to do when we do parametrics. So I'm just going to write it right now while we're going over it. So add this on to your notes. When we do parametrics, we have, do you remember parametrics? We have x in terms of t and y in terms of t. Do you remember that? So we can do the same formula, but in terms of t instead. And I'll get to your question in 1 second, Sarah. And so this is integral square root dx dt squared plus dy dt squared dt. Okay, so that's your third formula. Add this one on for your...
What should the bounds be?
Well, these ones will have x bounds.
Yeah.
These ones will have y bounds.
Right.
And this one will have t bounds. So it'll be from like times 0 to times 7, you know. Okay, Sarah, did you have a question?
Yeah. Are we gonna need to know how to, like,
Get to this
Yeah.
formula? No, you just need to memorize these 3 formulas.
okay.
Okay? So actually, these are really easy questions. Whenever it asks for arc length, just pull up one of these 3 formulas. Depending on whether it's in terms of x or in terms of y or in terms of t. Okay? So yeah, as long as you memorize these 3 formulas, that's okay. But that's where they come from. All right, so the last 3 problems are really easy. It's basically just use these 2 formulas that we've made to find the length of the curve. So for this one, I can do it in terms of x, which is my values are 1, 4, and it's square root of 1 plus dy dx squared. So what is dy dx? 3/2 x to the 1/2, right? So this is just integral 1 to 4 of square root 1 plus 3/2 x to the 1/2. Oops. All squared dx. Okay.
So will you always give us like y equals and then we'll find dy dx?
Mhm.
Okay.
Yep, it'll be like find the length of the curve, and it'll give you y equals, you find the slope, and then plug it into the formula. Then we're done.
And we can keep it like that, or do we have to solve that?
Then you would use your calculator to solve it. All of the arc length problems are either just set it up or use your calculator to get the decimal answer. The other way to do this one would be if this was x equals y to the 2/3, then dx dy is 2/3 y to the negative 1/3. So you could do another one. This is equal to the integral from 1 to 8 using y values of square root 1 plus, and then you can use dx dy. But that's both of them are equivalent to each other. But they both find arc length.
Wait, why did you use 2/3 and 1 3/2?
Because this one is dx dy, and this one's dy dx. So when you do it in terms of y, you want dx dy. But if you do it in terms of x, you want dy dx.
So you flip where it's to the power of?
What?
No, I solved for x here.
Oh, you just
Like I rewrote it as x equals, and then I took the derivative of it. I didn't like solve for, take this and transition it. Which you could, but it would take a little bit more work. Okay, so just write the arc length formulas for the last 2 problems. You only have to do it one way, and this is an x interval. So 1/2 to 2. Square root 1 plus, let's find dy dx. So 1/2 x to the
Square root.
second, oh geez, minus 1/2 half x to the negative 2. And on free response, if you're doing free response, I wouldn't even bother writing this in here. I would just go dy dx squared, because once you define it here, you don't have to, the AP readers will take this and they'll plug it into this here for you. So they will assume that you've made the right plug-in and you don't have to worry about doing it. Okay, so we're going to stop there, and then this one is integral 0 to 4 square root 1 plus, okay, for this one I need dx dy. So it's derivative of 1 is 0. 3 halves y to the 1 half, and then you just write dx dy squared dy, and then you're good. And you can just use your calculator to solve the rest of it. Okay? All right, arc length's not too bad. If you have any questions, let me know. I posted homework on Blackboard if you want to work on that for extra review. But when I see you on next Thursday, right? Yeah, Thursday, we'll have one standard on area and arc length.
Wait, I forgot we have